This would definitely be a level 3 or round 3 question. Here, if we look at what the question states, it's given that the distance penetrated by a missile is directly proportional to its penetrative power and inversely proportional to the thickness of the concrete wall it has to pass through. Thus, I get a generalized feeling of what the question is saying, and it states that the distance that is penetrated is directly proportional to the penetrative power upon the thickness T, which means that distance is equal to some constant into penetrative power upon thickness. Now the question states that the penetration power of a missile is just enough to reach the inner side of the spherical shell of a bunker of outer radius r and inner radius small r. So here what I can state now is that the distance penetrated would be equal to k into penetrative power by the thickness, which is nothing but the difference between the outer radius and the inner radius. Also, it is stated that the penetration power of the missile is just enough to reach the inner side of the spherical shell. Thus, the distance that would be traveled would be nothing but the thickness in this case. Therefore, D is nothing but capital R minus small r. Hence, I can say capital R minus small r is equal to K into P by capital R minus small r, which implies capital R minus small r whole squared is equal to K into P. The second part of the question now states, if the penetration power of the missile becomes 4 times and the bunker's inner radius remains constant, then by how much should the thickness of the outer surface of the bunker be increased so as to just stop the missile from entering the inner shell? Again, going back to our original equation, which was D is equal to K into Pt, we see that D in this case becomes K into 4P, and the thickness here would be the outer radius, which we can call capital R dash, minus the inner radius. The distance again would be nothing but the difference between outer and inner radius, which is equal to K into 4P by capital R dash minus small r. This would mean capital R dash minus small r whole squared is equal to K into 4P. Now if I just divide the two equations that I have obtained, I see that capital R dash minus r whole squared by capital R minus small r whole squared is equal to 4. So I can say that capital R dash minus small r is twice capital R minus small r, which implies capital R dash is equal to twice capital R minus 2r plus r, which is equal to 2r minus small r. Thus in this case, if you look at option A, it is correct.